Welcome to Opening Voices. I'm Quentin, the CEO of Clever Cloud, and today I am inviting André Loesekrug-Pietri. André is the leader of JEDI, Joint European Disruptive Initiative. The goal is to create a European DARPA. That's a good idea. So, hi everyone, we're still with André Loesekrug-Pietri from JEDI. We're still using AI, so if we don't listen us in English, it's a deep fake and we assume it. So we discuss about the different way that the program work, and maybe it can be interesting to have different method and approach to be able to manage crisis or very large change in a society like us. One of the points I want to ask is, when we say about the funding of technology, people doesn't really understand that you say that the public sector and the private sector have different kind of level. For me, one of the points was saying that there is a difference between research results, technology, and product. Can you maybe elaborate and speak about the different levels of what is this kind of stuff, and maybe linked it to something that we use in research program funding, which is a TRL, technical readiness level. So maybe it's something we can discuss a little bit there.
I mean, TRLs are used, by the way, they're coming from both the scientific community in the US and from the Department of Defense. Interestingly, some of these technology readiness level go from 1 to 10, some go from 1 to 12. So it seems to be an objective way to measure if something is still in fundamental research in the lab, if it's already at the prototype level, or if it's already a product that can be commercialized. Basically, under 5, you are in the scientific and pure fundamental research level. Over 5 or 6, you can begin to approach the prototype. What is interesting, and that is also an inspiration we got from ARPA, is that what we see today, and I will again take the example of the pandemic, is that you have more or less a merger, not a complete merger, but at least increased closeness between fundamental research and applied research. Again, in 2020, we saw between January 2020 and October 2020, when the first vaccines came out, you had fundamental research steps which were taken. You were then on RNA technology. Then you had applied research, for example, how to embed RNA strains on lipidic substrate, which was in order to keep the RNA alive and
not destroyed by the humidity.
And you remember how it needed to be kept at -70 in special fridges, etc. And then you had the industrialization, how you scale it and produce millions or billions of vaccine. All this happened in 8 months. So those who today still talk about fundamental research as being radically separate from applied research don't see that increasingly with the compression of time, again, the time factor, these two worlds are coming together. And what really ARPA invented and what we try to emulate...
In the same way for AI today, what does OpenAI compressing the time? It's basically like everyone is running after OpenAI because they are leading the course.
They are leading the course, and you see increasingly that privately owned companies are increasingly have a fundamental R&D budget that is similar or even larger than states. When you see what is happening in the quantum domain at companies like IBM or Google, you have fundamental research which would be relatively similar than what you see in labs like the CNRS or Jülich, or Jülich is a computing center, or Max Planck or others. So,
but with less bureaucracy and paper, because
less bureaucracy, but on the other side, these companies have their own shareholders. So how do you mix between something which is going to benefit the whole society and something which can be a game changer? But this is definitely a new phenomenon.
In the kind of research is researcher in private company does research, and reporting to the shareholders is made by someone whose job is reporting to the shareholders. And I think I remember that you tell me that Alain Aspect have some. So Alain Aspect is Nobel Prize of Physics in quantum, and basically he spent like 25 to 30% of his time in paperwork.
It's better that himself says it, but yes, what we see, maybe two things, just to finish on this thing on fundamental versus applied research. Acceleration of time will make it increasingly critical that the test by the market, the product, the industrialization has a feedback loop to research, and having it's a little bit like industry and research. When you don't have, unfortunately, that is what a country like France experienced. We thought 20 years ago that we could only keep the research centers and don't need the industry. Well, when you don't have the industry, you don't have the feedback with the market, with the product that can immediately feed and generate new ideas for the new products. So you need these two things together. And increasingly in technology, if you don't have the advanced research, the scientists that are working on the new generations, you are losing the game on the industrialization. And so we need to keep these two things together.
The AI topics, basically, if you don't have the search index and the social network data set, it's complicated to do AI research. So that's why this kind of company are very closely to the industry. And that's why it's very important to make public sector and private sector work together, but more to favorize an industry to actually exist. If you want to do research on nuclear fusion or fission, you need Orano and some nuclear data plant to be able to actually see it working in production.
Which is the complexity of the world of today, is that increasingly we need to be very deep in a sector. You don't have a doctor, you don't have a cardiologist. You have a cardiologist which is focused on the left ventricle and others who are working on the tissues, etc. And on the other side, most of the challenges we are facing are transversal. And AI is a good example for a technology which is radically transversal. So having both the depth that you need to be at the forefront of science and this capacity of working as an ecosystem requires probably a radically different type of organization. And that's why where really we are hitting sometimes a wall is that our traditional administrative systems, especially government, which is probably not at the forefront of, I would say, the most advanced management, have difficulties to work along the silos. And unfortunately, I have a deep conviction in the European project, but we radically need to change the way the EU institutions are working. I give an example. I talked about energy transition. Right now, we know that energy transition is dependent on these new materials, especially rare earths that are critical for permanent magnets. If you need an offshore windmill, critical for energy transition, you need these permanent magnets. 92% of them are refined in China. We should
92%.
92%. So imagine
and understand that.
Imagine the dependency that we're building up towards China today for our Green Deal is probably much higher than the one we had with Russian gas and oil 3 years ago. But so the natural consequence should be that we have a focused research program that is concentrated on finding alternatives. Well, you have the Green Deal and the DG Climate, and you have the Director General for RTD. They don't really talk to each other. They will tell you they talk to each other, but the work program of the DG RTD is there for 7 years, for 2020 to 2026. Very difficult to change. So this unagility is really crippling our capacity to be agile at the moment where, one, you need to be agile, and if you are not, again, at the forefront, others will impose their technology, their future, and we will lose our sovereignty. It's a sovereignty, it's a democratic challenge that we are facing.
And for me, there is also a question of a culture, because when you speak about high magnetic materials, every engineer in the room understands immediately the impact. But if you talk to someone which is, I don't know, historian aggregate, for example, you will have someone which say, okay, cool, it's magnet. I put it on my fridge, but don't really understand what is the current implication of what you say about it. And I think we still need to switch a little bit the cultural challenge of Europe, which are the people managing the research are not researchers.
Well, this is one of our side projects, is how do we ensure that we ramp up what we call technological intuition or understanding of our political leaders, because increasingly science and technology is core to, we talked about economy, geopolitics, future of our democracies. And if you don't understand these topics, it's very difficult to set up the right regulation, to take the good decisions. I will be very straightforward, and I'm not going to make a lot of friends with saying that, but when in the DG competition, which has to make decisions on mergers and acquisition, 85% of a team is made from lawyers, it's very difficult for them to understand the technological understanding. I give an example which is really for me incredible. In 2014, when Facebook, Meta now, acquired WhatsApp, there is a sentence, page I think 116 of DG Comp's decision allowing that merger or that acquisition, saying WhatsApp is not in competition with Facebook Messenger. I mean, it's written black on white. So that means I'm not calling for only scientists. It's great to have lawyers, but you need diversity. When you see that out of the 27 heads of state at the EU, only one has a scientific background, we have an issue. And unfortunately, you see our value opponents or our adversaries in non-democratic systems, unfortunately, are very often made of leaders who have more an engineering background. We are calling for something like in the US, which is called the Office of Science and Technology. Yeah. It's in the famous West Wing that everybody knows in the White House. You have 120 PhDs in different fields who are advising the president on the CHIPS Act, the synthetic biology strategy. And these are not 150 pages. These are 5, 10, 15 very strategic and scientifically sound documents that allows to have a clear vision.
But it's the opinion of the guys which have been selected to be there. And I think there is 2 points there. It's have a scientific background and make trust to someone you selected to his scientific background. Because there is something I often say, that every founder or manager of one of the big tech in the US have always been a PhD or an engineer. Always. Even Eric Schmidt have a PhD from Berkeley Science and have written Lex. It's not the commercial guys who help the too youngs, you know. So basically what we need is to be able to trust some engineer. I have one question before to go to the next part of our conversation. In every big tech we see today, which are the top 10 companies valuation in the world, does any one of them have not been in contract with DARPA?
I don't obviously know, because DARPA contracts are not public in many cases, but they're often talked about. I would make a bet that no. I think all of them have been in touch, because I mean DARPA is not huge in terms. I mean, it's a lot of money, and we expect and hope we'll have the same kind of budget. But I mentioned to you what I really believe. I don't think it's a question today of money. It's a question of approach, asking the right question, trusting the right persons, and considering speed as important. We desperately need that in Europe. But DARPA has always been basically at the cutting edge. It also inspired. I mean, you have an organization within Alphabet, Google, that is called Google X, which is called the Moonshot Factory. By the way, we at JEDI, we call ourselves the European Moonshot Factory, which is here to help Alphabet and the two founders to really think about, you know, what could come next. And you see increasingly a lot of organizations who are there, and they don't do that only to be, to have a societal contribution. And I don't know how many industrialists will listen to that, but I think increasingly for our large industrialists, you don't have the traditional innovator dilemma. You need to ensure that you are creating the future and the future product, the future business models. Otherwise, others will do it, and it can happen very fast. I mean, look at what's going on in my other country. I'm both French and German. In Germany, look at how we are looking almost in real time at the, I hope it's not the disappearance, but at the crash of the automotive industry. I mean, 2 years ago, they were still having record numbers. We see that in real time. I think this acceleration is something that people see with a lot of, I mean, they're petrified. Our message is positive, is to say, taking the example of OpenAI, Europe for 15 years has tried to create a competitor to Google. So we tried, basically to play a catch-up game to do, keyword search. Well, OpenAI came with a radically different approach of saying, okay, let's do more natural language, prompt engineering, etc. And they made Google search looking a little bit has been. I trust Google will catch up and will have its own model, but still, it has that. But the question
Google is struggling for its life right now.
Absolutely, and we should ask ourselves, why have we not been able, despite the Plan Villani, the AI money that was invested by the EU and other countries, why has this generative AI not been created? And so we should ensure, and I could say the same, I think all our viewers have seen these incredible images of Starship coming back. It's the same thing is happening in space. How do we ensure that Europe invents the future?
Can I say just something important about space, and just right now? Today, the guy who is managing Ariane Espace is an historian.
I mean, I hope this will not be a video against historians. I think we need to understand our past.
But we need not a video against historians. But at some point of the tech industry, you need to be able to go to the factory and understand why every piece is there. And when I have done some industry, I have basically creating myself the stuff once or two, and after you give it to workers that are better than you, much fast, more precise. This is not the point. You need to understand what you do.
I mean, your point is super important. We believe at JEDI that we have entered this world of big bets. And if you want to make bets, you need to be able to understand what is possible today and what could be possible tomorrow. If you don't understand it, you will, of course, remain relatively conservative. And like somebody explained to me a couple of weeks ago, when you're in the river, I mean, you will not try to go on the banks. You will rather remain in the center. But if you remain at the center in a world that changes very quickly by leaps, you will for sure, if you don't do these bets, you will for sure lose. That means at the procurement level, at the political level, at the R&D organization levels, you need people who understand their stuff very well, but also, and I will add something that JEDI is also putting in place, you need to have people who often rotate. DARPA has this rule that the program manager has a 2-year contract, renewable once, but after 4, maximum 5 years, he's out. It's not that he's bad, but they want at all costs
to get back to the research.
To the research, but also they don't want to have people in the organization that will say, yes, but we tried that 5 years ago. I give you an example which is very clear. Drone swarms, which is probably one of, if not but one of a big threat for the current defense organization, because they might radically change doctrines for naval engagement, for terrestrial engagement, etc. 5 years ago, computing power was not sufficient to have swarms that are more than a couple of drones. Today, you have swarms of 4,000, 5,000 even more drones working together. So if you had looked at this program 5 years ago, you would have said, not possible, forget it. So you need to revisit these topics. And this is going to be increasingly the case. New material science is progressing so fast that you are able to produce things that were unimaginable 2 years ago. Capacity of developing new drugs was impossible, for example, to fold proteins. That's where DeepMind made a big breakthrough. Today, you are able to understand much finer the structure, the interaction of proteins together.
Fold the protein.
You're able, and this is one of the biggest. And I think you are going to have leaps in quantum, which is going again to radically change the way we look at algorithms, for example.
To conclude about this part, and before a small part about the people, to conclude about this part, maybe we can say in this research centuries, which is the technical leap, which is exponential today, what you need is to be confident about this technology. And that's basically what drives the 10 more profitable, the 10 more valuable company of this world. So until next week, André.
I see you next week, Quentin. On this thing on technology, I think it's super important. I talked about the fact that we need not to do, and that is probably an opportunity for Europe, is not to do technology for technology. We need to be able to explain to our citizens. I'm never very comfortable when I hear we have an AI strategy or we have a quantum strategy. I mean, these are tools. What are we trying to achieve for society? And I think by explaining that, number one, you get much more people behind you because they understand it's to create better drugs, is to create new type of production forms that can be done at cost in developed countries and not need to be put in developing countries and losing our industry on the way. We need to show we can do AI by consuming much less energy. I think these things are programs which are much more inspirational for our society. And that's, by the way, also where we will get support by policymakers to put also the budget that we need to put in these strategies.
Thanks for listening Opening Voices. We will continue in a few days the interview with André Loesekrug-Pietri from JEDI. So subscribe to the YouTube channel or the podcast to continue with us.